In this lesson, lesson 20, we're going to be talking about area of composed figures. Let's look at our lesson objectives. First, we're going to talk about the content objectives. We're going to learn how to find the areas of two-dimensional objects composed of triangles, quadrilaterals, and polygons. We're going to apply formulas to solve real-world and mathematical problems. And then we're going to use equations to represent problems involving area. The language objectives. Hopefully you'll be able to say this. I can explain how to find the area of composite figure by speaking and writing complete sentences. I can describe the steps to finding the area of an irregular octagon using the terms right triangle, rectangle, base, and height. I can discuss solution methods using precise mathematical language. I can read and interpret word problems about the area of composed figures by identifying the question and key information. Let's look at the prerequisite skills. Skills you should already know or have learned. Compose and decompose polygons. Use formulas to find the area of triangles and rectangles. And remember, you have your reference sheet so you can look at that. The vocabulary for this lesson, there really isn't any new vocabulary. So we will review the following key terms. Composite figure, it's a figure made up of two or more simpler figures. Decompose, to break into non-overlapping parts. And region, a specific area. And here's why we're doing this, the learning progression. In grade 6, students, which you, found the area of right triangles, other triangles, special quadrilateral, and polygons by composing figures into quadrilaterals or decomposing figures into triangles and other shapes. In this lesson, you will build on the understanding of composing and decomposing figures, using it to find the area of complex figures. They also practice representing problem situations with algebraic equations. And next year, students will decompose a square in two ways to explain why the Pythagorean theorem is correct. Students will also continue to reason about the relationship between 2 and 3-dimensional shapes. Let's look at what we know. In previous grades, you learned that you can find the area of many different shapes by breaking the shape up into rectangles and triangles. Take a look at this problem. Maya's garden is made of rectangular regions, as shown below. She wants to cover her garden with plastic mulch to warm the soil. What is the area of her garden? I want you to look at this problem, and I want to see if you guys can figure that out. As you should pause this video right now and see if you can figure that out on your own. Well, now let's look at how we can find the area of her garden. Okay, so here's some clues. There's some great questions here that we can give you, okay, to be able to find the area. So the first thing, it says draw 2 vertical lines to break the figure up into 3 rectangles. Vertical means to go up and down. So what they're doing is they're saying to draw another vertical line here and another vertical line here. And now if you look at it carefully, we have 3 rectangles. 1, 2, 3. As I'm assuming everybody can see that. Okay, and now let's start answering some of the questions. The rectangle at the left is 50, as you can see, 50 centimeters by 20 and a half centimeters. Can you guys see 20 and a half centimeters? So they're asking you to find the area. So I'm going to give you an opportunity to find the area. I would pause this video and see if you can find the area of that. The next question says, one of the dimensions of the rectangle in the middle is 40 centimeters. What is the other dimension? So we know that this is 40 centimeters. How would you find this length? How would you find this length, the length of that line segment? Well, I want you to think for a sec, and then I'll give you a clue. Again, I would pause this video to think, and then I'll give you the clue. So now I want you to think about this whole line segment here is 50 centimeters. And if this line segment here is 20 and a half centimeters, what do you think the measurement of this, alright, line segment will be? So if you obviously take 50 minus 20 and a half, you get your answer. So I'm hoping you guys did that or thought about that. Once you have that length, then you can find the area of the middle rectangle. So I would go ahead and find the area of that. Let's look at question E. It says, what is the area of the rectangle at the right? This is the last one. So obviously we still got to find this length. We are given this length, which is great, 20 and a half centimeters. But what's the length right here of this line segment? So if you look at the question, it says, what is the area of the rectangle at the right? And explain how you figured it out. Well, obviously we have this length, but we don't have this length. So they're asking you, how would you figure this length? I want you to think the whole thing right here is 70 centimeters. All right, and then we have the 40 centimeters, and then we have the 20 and a half centimeters. So that's being able to think at a high level. After you found out the length here, obviously you can find the area of this rectangle, and then please explain how you figured it out. And then question F says, how can you find the area of the figure? Okay, and then question G says, find the area of Maya's garden. In this page right now, what I'm going to do is I'm going to reveal some of the answers. I want you to look them over, and then I want you, for those who are struggling with this, first of all, if you got the right answer, just put a nice check next to it. It seems like you're understanding this. But if you didn't, I would go back and recheck and understand that again. So I will show you the answer one by one and give you about 10 seconds in between each question, and then look them over. Now that you have all the answers, again, if you need help, go back and restart this video and check it all out and do some of the work. Good job on the first part.